Welcome to the Drowned Ant Farm Groundwater Model of Science, or Atlantis. In the model we have two aquifers, an upper aquifer and a lower aquifer. The two are separated by this fine-grained layer here. There's a number of piezometers, or observation wells, in the model, and they give you the water level, or hydraulic head, at the point at which that observation well is open. So they're open here, here, here. And you see that some of them are open in the lower aquifer, while the majority of them are open in the upper aquifer. The model is filled by reservoirs on the sides here, in this section here. And in the middle of the model, we have a cross-section of a stream channel, which can fill. And the drain here, which runs off, is to simulate stream flow. So as the channel fills, water can flow down the drain just like it would flow down the stream channel. Okay, so the first thing we're going to do is draw in the water table. And to do that, we need to mark the water level in each of the piezometers in the upper aquifer. I will not do the piezometers in the lower aquifer. And we'll also mark the reservoirs on the sides, since this is the head at the edges of the boundary. And we'll also mark the level of the stream. So I will do tick mark there, 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 there. All right. Now we have the tick marks, we smoothly connect them, and we have our water table, which is the level to which the aquifer is saturated with water. Above that, there is less water there than there could be. The pores are not completely filled. Right, so that's our water table. Now, since water always flows from high head to low head, or high elevation to low elevation, you can look at the water table and you can tell which direction the water is flowing. So now you can sketch in some arrows to show the direction of groundwater flow. Okay. Now what we'll be doing next is turning this piezometer into a well by pumping out of it, and we'll observe what happens to the water level around the well when we do that. Now I'll use a syringe and this tube to pump water out of this well, and we'll observe how the water level changes here as well as the other piezometers that are in the upper aquifer. Now we can see how the water table has dropped, and it's dropped the most right at the well, and that amount that it's dropped is decreased as you get farther and farther away from the well. But it has dropped the table enough that it dropped the stream level a little bit as well. Next I'll play two clips that will give you an idea of what groundwater flow sort of looks like. So I shot them when the model was first filling, the sand was completely dry, and so it's very easy to see the front of water move through. Now this isn't actually saturated flow, it's unsaturated flow because there are capillary forces pulling this up, but it'll look about the same, so I'll just give you an idea. Both clips are sped up by a factor of 4. Now finally, we'll take a little food coloring here, we'll drop it into this well and use it as a tracer. We'll be able to see that dye move through the system. So you can imagine this as being like a contaminant, and make this a little more realistic. Instead of this being a well, perhaps it's a tank buried beneath a gas station for holding gasoline, and that tank is leaking, and so we'll be able to see the gas move out of that tank as it moves through the system. Here you'll see about 20 minutes of time compressed down to 25 seconds.